Small wind turbines are inefficient, expensive, and unreliable. We set out to fix that. This is the Variable Tilt Axis Wind Turbine, or VTAWT. To meet the UN Sustainable Development Goals, we need clean energy that is affordable and local. That's the promise of distributed renewable energy generation. Small-scale, localized power systems that operate independently or alongside the grid. Distributed power generation means two options: solar photovoltaics, PV panels, and small wind turbines. While solar has seen massive investment and rapid cost declines, small wind hasn't kept pace.
This graph tells a story. On the y-axis is energy cost per kilowatt hour, on the x-axis system size. As wind turbines get larger, costs drop, but look to the left, small wind costs spike. Meanwhile, solar stays low across all sizes. Why? Imagine a solar factory, same panel, same price, no matter where it's installed. Now imagine a wind turbine factory. Every size needs a different design. Small wind doesn't scale the same way. That's the cost problem. Our goal with VTAWT is to boost energy efficiency so each turbine captures more energy, especially in varied environments. More energy captured means lower cost per unit and a path to make small wind competitive. Here's how the variable tilt axis wind turbine works. We start with the turbine in its upright position, just like a conventional wind turbine. But in the real world, wind doesn't only move horizontally, especially mountainous or sun-heated environments. Upward thermals, rising columns of warm air are a major untapped source of wind energy. When both forces are present, they combine to create winds pointed upward, and that's where this wind turbine stands apart. It doesn't fight the wind, it tilts to match it. The system actively adjusts its tilt angle, aligning the rotor plane with the resultant force to capture more energy for an increased capacity factor. This adaptability allows the turbine to operate across a wider range of conditions.
Let's take a closer look at what makes the VTAWT work. The blades are custom designed using the AF300 airfoil, optimized for low-speed wind, perfect for small-scale systems. We use both simulation and testing to fine-tune their performance. At the core is the tilting subassembly. A stepper motor and controller adjust the tilt in real time to match the wind, maximizing energy capture. The nacelle holds the generator and dampens vibration, with room to fit different generator types for flexible deployment. Altogether, this makes VTAWT a modular and adaptable system, ideal for local production and optimization, not competing with solar's scale, but offering smarter wind solutions for specific environments. The VTAWT is designed to operate in a wide range of environments, from coastal areas with strong upward thermals to urban rooftops where the heat island effect drives vertical airflow. This adaptability is core to its performance. In testing, we validated a 14.11% boost in power output from thermals, matching our simulations. Over its lifetime, the system shows a 9.48% increase in total energy capture and a 4.91% reduction in levelized energy cost compared to conventional small turbines. Small design changes paired with smart control can drive big gains in distributed wind generation.
Here's what that tilting system looks like in action. On the left, our wind tunnel tests show the turbine actively adjusting its tilt to match the optimal angle. It consistently isolates the ideal tilt angle in real time to maximize power output. The graph shows the results. The blue line shows performance with no upward thermals, where staying flat or horizontal works best, but the orange line shows a different case when upward thermals are present. Here the turbine finds a new peak at a 9-degree downward tilt where it aligns with the combined wind force. The small adjustment leads to significantly higher output, proving the tilt system works. It adapts in real time and helps capture more energy, especially in changing wind conditions.
Here's where the system becomes truly impactful: real-world rural electrification. By pairing the VTAWT with solar panels, we create a hybrid renewable system that significantly boosts energy availability. Solar alone has an average capacity factor, how often the system is actually generating power, of about 16%. But with the VTAWT integration, the hybrid system is able to achieve up to 39% capacity factor, a 141% increase over solar by itself. This is possible because the system is wind-dependent when cloudy and solar-dependent when sunny, adapting to environmental conditions to keep delivering power. This kind of flexibility makes decentralized generation much more viable, especially in off-grid or underserved regions. Hybrid renewables like this one aren't just cleaner, they're economically competitive. And the VTAWT makes wind a serious contender in that space. Thank you for listening.